there are two ways you could reach someone by phone. You could call them at home, or you could call them on their work phone. How many of you still have a phone at work? I don't. It's not that many. So today, a person has a cellular phone, a Skype number, a Zoom number, WhatsApp number, and whatever else is going to be invented next month. So if this is great for us, it's not so great if you were a data architect and you did a lot of these designs a few years ago, where you would model the different mode of communication to reach someone as a column in a table. So we would have one column for the home phone, another one for the work phone. So welcome to my presentation on data modeling. Today we'll talk a lot about data modeling, how to design, but also how can we evolve cleanly a model that requires changes over time. So I'm Daniel Coupal, been in the company for over 8 years. Many of you probably know me from the education class I participated. I work on the data modeling class. I created a bunch of blogs for data patterns and anti-patterns. In short, I'm passionate about anything MongoDB, especially for data modeling. So our presentation will be divided into 3 sections. First, we'll talk about the need to model for NoSQL. Then we'll introduce some techniques to help you do that model. And finally, we'll dig a little bit more deeper into the schema versioning pattern, which is my favorite pattern. So let's get going. We have a lot to cover. So we model anything because we need to face an answer to constraint. If there are no constraints, you wouldn't need to model. The example I like to use is air. We don't need to model how we're going to breathe because it's all there around us. However, if we're going to go to space or underwater, we need to develop a model for that. So what are such constraints when we do a system? Well, you have physical constraint. The network speed is not infinite. Putting data in one location and having users from around the world trying to access it, that's going to be slow. So it's something you need to care for. Hardware. Reading and writing to hard disk is pretty slow. Using RAM is much faster, but it's also more expensive. So there's a compromise here. And the hardware, either if it's a VM or a physical machine, they will require maintenance. Patches for security, patches for the OS, upgraded the version of the software. And then finally, you also get constraint from the software packages you're using, like MongoDB, for example. MongoDB imposes on you a limit of 16 meg for the document size. And there's also some functionality that may not be at MongoDB when you started your design. So these constraints are going to be mapped to 3 different parts in our architecture. Either the application will take care of it, MongoDB will take care of it, or it could be the infrastructure on which you're running. So what interests us, obviously, in that presentation is what MongoDB is doing in terms of functionality. So the second axiom for this presentation is that it's imperative to know the features of the product you're using. And what are such features? Well, in data modeling, the most important, obviously, is the document model. So understanding the document model will get you a long way. Indexes, that's the most common issue we see with customers that have performance issue is they're not using the right indexes. Sharding, you have a large database. How do you shard? What are the important concepts? And then there's things that came more recently in the last few years, like transaction, field-level encryption, or data federation, archives, et cetera. What's interesting is when I joined, a lot of these features were not there. And if, for example, if you had to do a transaction, you would use a double commit for it. Now we do have transaction even for sharded clusters, and it's exactly the same syntax as what you maybe use for a relational database. Encryption, using the field-level encryption, probably the best security feature of any database out there. In the past, it would be pretty complex, managing your own key, encoding every single value, and doing all the work. Now, it's included in MongoDB. The driver and the server take care of it, and it's extremely powerful. Doing archiving. If you have data that you want to keep for a certain number of days or years in your database, and you need to keep it for even longer, but you're not going to access it. You want to put it in a place where it's cheaper. So in the past, you could use different collections. You could build all these mechanisms to do that. It's always been there. It would be in your model. But now if you use Atlas, the feature is as simple as answering a few questions, 2 pages of questions, that's it, and you have an automatic archive. And obviously search that came recently in our product. Basically what I'm saying is the things will change, and your model may also need to evolve over time based on the fact that new features appear in products. We sometimes can't predict what's going to happen. So for this presentation, we're going to use a little example of a social network for chefs. So our chefs are going to come, they're going to write articles, recipes, whatever, and then we're going to take these articles, we're going to categorize them, we're going to put tags on them, and we're going to have a bunch of users who can come and can comment on the different articles. So very simple model system here that we want to do. If I ask you to go and model that with a relational database, all of you will probably come out with that exact solution, because there is only one solution that respects the third normal form. And that's it. Relationship between things are intrinsic. They're either one-to-one, one-to-many, many-to-many. And they're always the same. So if you normalize your model, it will look like that. Now, if I ask you to do the same model for MongoDB, well, you may have a solution where you say, well, I'm querying articles all the time, so we're going to use article as our main collection, and we're going to embed all the information in. Looking at that, we may say, you know what? If I do that, I'm going to be duplicating the information about the people. So I want to extract the people so I can do only one update. So that could be a different model. Now, which one is the right one? Well, the optimal grouping of objects into collections is determined by the workload. So you need to understand your workload. And that's going to bring us to the second part of this presentation. So we're going to introduce the methodology to do the modeling. And as you may guess, I'm just talking about workload, that's going to be the first phase of our methodology. We're going to address the workload. We're going to identify it. After that, we're going to identify the relationships between the different pieces of data. And then we're going to identify patterns and apply those to our solution to make it better, more performant, et cetera. So those of you who follow that and are used to do model with the relational database, you probably see here where I'm going. In a relational database, we often start by going in a room with people, draw an ER diagram, go back to our desk, write the code. Something is slow, then we're going to apply the normalization. So we do the data model first, and often the workload identification secondly. With MongoDB, we're going to swap those two operations, those two phases. We're going to first think about identifying the workload, and then we're going to go and do our data model. And this is not just for MongoDB. It's for any SQL, any NoSQL database. And it's not really just because it's NoSQL. It's often because it's big data. There's a lot more consequence of having the right model when you have operation that happens 100 times per second. So that's why identify the workload first to be able to create a model that's going to be good and give you good velocity on the important queries is going to be crucial in your modeling. So what do we do to identify that workload? Well, we're going to size the data. How many of these documents am I going to have? What's going to be their size? I'm going to quantify the operation. What are the write operation I'm going to be doing? What are the read operation I'm going to be doing? And then we're going to qualify those. So we got numbers, often they happen, but maybe there's other things like security-wise, consideration for archiving and all that. So the important query is going to go, we're going to go a little bit more deeper in them and put more information. Once we get that, we have a good description of what the system is intended to do. So let's go back to the example we have of our little system. The first operation I may have is a write operation. I'm writing new articles. So this is really crucial for my system because I don't want to lose those. This is the core of my system. That's the most important part. So I'm going to treat them in a different way. My user is going to come and comment on the different articles we have. So we're going to have a little bit more of that, 10,000 a day, still not a lot. Then we're going to have people who come and read an article. So this is another scale. We're going to get 10 million of those per day. And finally, we're going to also have analytic queries. Not a lot, but those tend to be disruptive. And that's going to give you, if you start writing all those operations, this is going to give you some indication that you may want to have an additional node just to do the analytics to not disturb the workload if the workload is going to peak. So a lot of information was given this morning about everything we do for analytics, and using that is going to help you for performance of those. So looking at all these operations, it's pretty easy here to narrow it down to one. That happens a lot more than the other one. So if I want to optimize my systems or my reads are very fast when people come and they see an article, that is the query I'm going to have to take care of. I'm going to have to model for it. So I take that important query, and then I dig deeper into it. What's the latency I want to have? Data lifespan. I talk a little bit about the archive. So maybe that article has to be accessed quickly for 3 years. But someone wants to read an old article. I don't want to pay the price. I'm going to put them in the archive in S3, something, something that's a little bit cheaper for me to manage. And maybe you have also security requirements like GDPR, the right to be forgotten. And that specific query is important for that. So we can best act on new hypotheses if we know the original hypothesis. So basically what I'm saying is if you write down what you were expecting for your workload and you put information there, things change in the future, it's a good indication that you have to go back on the board and see the impact of having this query that was supposed to run 10,000 times per second, but now is running 50,000 times per second. So coming out of that phase, we have a good description of our workload. Now we're going to move at identifying the relationship. We're going to also quantify them, a little bit more on that later. And then we're going to answer the most important query, the most important question that when you're modeling for MongoDB. Are you going to embed or reference the different piece of information? I like to use the following to illustrate the difference between modeling the relationship in a relational or tabular database. I like to use tabular because MongoDB is also relational and has maybe even more ways of expressing relationships than something like Oracle. But if you're using a car and you want to bring it in your garage and it's a relational garage, you're going to take the wheels, you're going to put on one table. You're going to take the seats, put them in another table. And then when it's time to use your car again, you're going to make that query that will do all the join and will give you back your car. When you model for MongoDB, all the parts that are used together are stored together. Okay? So what is used together in the application is stored together in the database. That should be a very good indicator of how you're going to put your information in collections. So what are the rules that's going to dictate if we should reference or we should embed? Before I go there, just to be sure that it's clear for everyone, in a relational database, it's always reference. You have two tables, and you have a foreign key that helps you identify the relationship from one to the other one. In MongoDB, we call that linking or referencing. This is in contrast with embedding. Embedding, we're going to take one of the entity and bring it inside. And we're going to use an array for that. In the document model, an array is the expression of a one-to-many or many-to-many relationship. So that's how you put two entities together. You use an array. So if you look here, the comments for an article, it's a one-to-many relationship. And when I talk about quantifying the relationship, I like to use numbers like that, which is my minimum and my maximum. And if there's like a most likely number, I will also add it. Could be 0, 3, 1,000. Why are we doing that? Is because in the world of big data, this embedding thing, if it's 1 million, is going to have consequence. So I want to know about it. And that's why I'm going to use these numbers. I'm going to quantify my relationship, not just using many, but dig a little bit more deeper on that. OK, so what are the rules that's going to help me decide if I reference or I embed? When the many side is a huge number, you probably don't want to embed that. MongoDB is going to have to read the whole thing in memory, and if you're not using the whole thing, it's not worth it. It's maybe better to keep things separated. I need to do write operation, and I want integrity on those. I write on many documents, and I want that for many relationship. I don't want to update many documents. I'm going to put those in the transaction. I'm going to write 2 documents. I'm good to go. When a piece of information is used, but not all of it. If I'm loading a document, but there's only a small section I'm using all the time, and there's a big section I'm not using at all, you probably want to put that aside, okay? Now, what are the rules that's going to dictate that I should embed? Well, integrity of read operation. Again, MongoDB support transaction. You can always create a transaction, read things, everything will be fine. But the nice thing you get about the document model is the document model is asset by itself. Making writes to it or making reads to it are always atomic. So my most important query should be using the document model, should be using a single document. That's going to make the system much more performant. So integrity of write operation for one-to-one or one-to-many, embed the information, everything is in one document. If the data need to be deleted or archived together, hey, referential integrity. If everything is in one document, I don't have to care about it. Delete the document, all the related stuff goes. I want to archive. Think about the problem of archiving rows in a relational database. I can't just archive the rows. I need to be able to also make joins to whatever all the other piece of information that they have at that time, so that row makes sense when I look at it 3 years later. In MongoDB, if all the information is contained in one document, you can archive the documents very easily, and they're complete in terms of information. And finally, my preferred rule by default. I like simplicity over complexity, and I think we often like over-engineer things. So embedding is going to give you a much simpler model. You're going to have code that's going to match your objects much more one-to-one when you do that. OK, so exiting that second phase, we have our collections. We've decided if we embed or if we link. What we have is still pretty much normalized at this point. OK, people say it's not normalized, but it is. Now, what we're going to do is we're going to look at that, and we're going to see where we can make improvements. How can we make this thing work better? And this is where our pattern is going to come into the picture. So who has read this software engineering classic from Eric Gamma and his friend? The cool thing about this book was not just the fact that they describe all those patterns. The cool thing they did is they created this universal language. So if you were going to go in a room with other architects who've read the same book, you could just reference factory, facade, and they would know exactly what you're talking about. So this is what we're going to be doing. We have a list of patterns that are the most frequent operation we saw in transforming the data with our customers. And then we have the main use cases. And this matrix I put together, which is the most likely patterns you get for each use case, not exact science. It doesn't mean that's the only pattern you're going to encounter. But that give you a good approximation of the things that are important for a given use case. And the one we're going to talk a little bit more about today, because it's very short, is going to be the schema versioning. That's going to bring us to the third section of our presentation, evolving the model with the schema versioning pattern. Any successful system will go through changes, likely including data model changes. If you don't have changes, it's because your product didn't live very long, or you were perfect on the first day, but it's still trying to find one of these projects. And the type of modification you're going to have on your schema will be either field modification or relationship modification most of the time. So a field modification is pretty easy. A relational database does that pretty easily. Alter table, change a type, add a column, whatever. It becomes a bit dicier when you try to modify a relationship. You have a one-to-one relationship, 2 pieces of information that are the same table. You're trying to maybe do a one-to-many, or you have a one-to-many and you're trying to do a many-to-many. Those are very difficult modifications in a relational database. So let's look at what it will be, what you would have to do with a relational database. So we have this table of users. And again, going back to our introduction, they have a home phone and they have a work phone. Now come a new user. Here we have Alton Brown. Alton has a Skype account. He has a WhatsApp account. He has a bunch of accounts like that. And we realized that, this is not scalable. We can't just be adding columns. We're going to do something a bit more flexible. The relationship is really one-to-many to the communication mode. And we want to break down the first table into 2 tables. So version 1 to version 2, the way we're going to do that, on Friday night, we're going to bring the system down. And then on Monday morning, we're going to have migrated all the data into our 2 tables, and then the system will come up. If you're going to do the same thing with MongoDB, well, we have our documents where they have home phone, work phone. Then Alton doesn't really fit into that mode. Alton's more like having all these new modes. So what we're going to do is create a sub-documents with communication mode. We could have had created 2 collection. It'll still be the same process. There's no problem there. So we want to get from version 1 to version 2. And the key thing here is the fact that we're going to add a version number. And this is not a version number of the document itself. It's not the content of the document. This is going to be a version number for the schema it's using. Think about it. When you're having a relational database, you have one version number for your whole database, for the whole schema. MongoDB, we're going to use the polymorphic attribute of the document models that each document can slightly be different. And we're going to piggyback on that to be able to read documents in different shapes. So what we have on Friday evening is documents that are in V1. On Monday morning, we want all those to be in V2. Well, we can go and slightly, one by one, update the documents. As long as my application is able to read both shape, version 1 and version 2, which means we will have to update the application first. If it can read both shapes, I don't have downtime, because as it's receiving a communication mode, depending on the version, it's going to do the right thing. So I'm not going to be down, so I can make my modification without downtime. So MongoDB not just let you develop and deploy quickly, but also evolve your application and your schema quickly. So in that presentation, we divided into 3 sections. So first, we had the need to model. So it's imperative to know the feature and the product you're using. And secondly, the thing to remember is the optimal grouping of objects and collection is determined by the workload. So it's very important to describe your workload first, identify those important queries, and refine them with more information, so you know that you're going to model because of those. And secondly, so the technique to model, we introduce a very simple model, 3-phase. We can best act on the hypothesis if we write that information. And now the big question, should you embed or should you link? Well, that question will be mostly answered very often is by, are you using these things together? So what you use together should be stored together. And finally, any successful system will go through changes, likely including data model changes. So MongoDB lets you develop quickly, but not just that, it will let you also evolve your application and your schema quickly, reducing maintenance costs over time, making things easier to develop. So to learn more, as I said in the introduction, I've written a bunch of blogs on the patterns, the 12 patterns that we have there, one more coming up soon. And we also have a series of blogs of anti-patterns, what you should not do. And that is to match something that Atlas can do for you. Atlas will, as you're running your application, will be looking for anti-patterns. Some examples are, if you're reading a document, and you're always, when you're reading this document, doing a lookup, which is a join to bring in information with it, well, you're probably better off to have this information together. Do you have large arrays that keep growing? So Atlas can help you for that. So more details, look at the blog series on the anti-patterns. We have classes, MongoDB University. How many of you have done a class on MongoDB University? It's getting a little bit better, but it's still not where it should be. First of all, MongoDB University is free for all. We're not there to make money on that. What we want is to be sure that you guys are trained and you're using MongoDB correctly. Because we know if you use MongoDB correctly, you'll get this aha moment, and you'll be really happy with it, and you will cut time to develop your solution. And then you're going to come back and you're going to develop more solution with MongoDB. But if you're using MongoDB and you're not using it correctly, well, it's going to end there. It's not going to be good for us. So we want to be sure you're using it correctly. 2 classes. One, the extensive class on data modeling is M320. We go over the methodology. We clear quickly on today. We go over all the patterns, all the different ways to model relationship, etc. And there's quiz and homework and all that for people who like that. Now, for people who don't like homeworks, just want something shorter, we have M100. M100 is a 2-hour class. So instead of watching 2 episodes of whatever on Netflix, you can just go and watch this class. There's no homework. It's going to go very fast. What we're trying to do in that class is for all of you who've been using relational database for a long time, and you're new to MongoDB, you don't know where to start, well, you're not really starting from scratch. It's still a database. Everything you've learned over the years, about consistency, about transaction, things that, it's just natural for you because you've been using database for a long time, indexes, they map to things in MongoDB. So what this class is doing is mapping all that knowledge that you have accumulated in the relational world to how to do it in MongoDB. And it's got you interested in things that are a little bit different, so you can go and read a little bit more about that. And finally, if you have a big project, don't hesitate. We have consulting engineers under our professional services group. And these are probably the most knowledgeable people we have at MongoDB. They're amazing, really amazing. And when they don't know something, they still have their team behind them. And they're going to come back to MongoDB, discuss with them, and they'll have the solution for you. So if you have a large project, you need some help in doing the data modeling or anything else, they're there to help. So some reference on the things I just posted earlier. I can't stay on that slide for too long because I need to put another one for the session. But that's going to get you directly to MongoDB University, to the blogs, and the anti-pattern blogs. So thank you, everyone, for coming. And this is the slide to get you to the review, the feedback for that session. So thank you, everyone.
All right. Thank you so much, Daniel.